Good evening. So this is the first show for Let's Talk Hack. Some of you guys might know that Let's Talk Network has been webcasting from Housepack in Centurion. And so all the equipment's here, so thanks for the mixer for coming in tonight and allowing us to use this equipment. And really the idea of the show is to sort of showcase here the hacks, what is happening in the hacker space, creating some awareness about innovation and so on. So the idea is we don't really want to put up like a formal show, but we'll have roughly once a month we'll have a sort of a series of videos. This being the first, and with each one with a central topic. Okay, so tonight's topic is all about USB reverse engineering, and Tom will do most of the talking here. So I don't know, Tom, if you quickly just want to say what it's all about.
Well, so after the whole reverse engineering of the Kinect, opening it up for the people to make their own projects with, USB reverse engineering has become a bit more of a popular topic. And while it's not extremely difficult, it is something with a few twists. So we've decided with our show tonight to just explain a few interesting ways of getting into it and to get started.
Excellent. So we called it Let's Talk Hack, and when we were sort of planning the show, we thought, okay, what do we actually mean by hacking? Because I think there's a lot of ambiguity around this word. Some people think about security, some people think about makers and tinkers and so on. But we sort of want to include all of that, perhaps not including bodily dismemberment, panga type stuff, but everything else. So that will be. So I think tonight is actually a very good a combination of what Tom will be showing. So there's some tinkerer stuff in there, but there's also some security and exploit type of opportunities for USB reverse engineering. So a good balance of what hack is, and we'll probably try to build on that in the coming episodes. So that's sort of the end of the introduction to the show. So the next thing is just introducing the people, the hackers that you're seeing around the table. So just introducing myself, I'm a freelance data scientist and Android developer. How I got into sort of data science and Android development is I did a PhD in electrical engineering at Stellenbosch in 2000. And since then I've been in the corporate world, and about a year ago started going on my own. Mostly because we started Housepack in 2011, and I met some awesome hackers, freelancers, guys that I love working with. And yeah, so that's me.
Hi, so I'm Toby Korean. I'm an electronic engineer, and I do Android as a freelance developer. I'm also an active House for Hacker. So Skulk and I worked together quite a lot on some innovative projects that we hope to show in future upcoming episodes. And I'm a geek in my late 30s, and I think that pretty much sums up what I am.
So Tom?
Over to Tom.
So hi, I'm Tom van den Bon. By day, I'm mainly a software developer in a hardware development environment. And by night, a geek, trying all kinds of weird and funky experiments and just learning new things. And I'm in my early 30s.
So, like I said, we're going to have a central topic all about USB reverse engineering, but we also want to spice it up a little bit with hack news and so on. So, Toby, maybe just take us through some of these things.
Cool. So, hack news for the first episode, right? Okay, cool. So, what's happening in South Africa? Well, here at House for Hack, which we generally run courses on a fairly regular basis, and this on the 2nd of February, which I think is this coming Saturday,
yes.
Is it? Yes, this coming Saturday, we have an Arduino course. So if you're not familiar with Arduino, it's a beginner's development environment, very beginner friendly. Even if you haven't done electronics, you can come here and you can learn about how to hook this stuff up together and learn how to build some hardware, right? It's actually a lot easier than you think. So that's happening this Saturday from 9 o'clock in the morning till 2 in the afternoon. Here at Housepack in Centurion. If you want to know more, I think the link will be put up. And that'll be presented by Skulk himself. What are the costs involved there?
Yeah, so $600 for the course. That includes the kit, which is $400. You're also welcome to source your own kits. The part are there. So if you think you can find it cheaper, please do, and also tell us where you found it. Otherwise, there's $200 then on top of that, which goes towards pizza and sweets and snacks on the day.
Cool. Awesome. I mean, that's fantastic value. Then also we have some new hacker spaces in South Africa, believe it or not. And Tom's running Binary Space. So this is in the Vaal Triangle. They meet on Thursdays at 7:30 in Van der Bijl Park. So if you're in and around the area, that's the place to be if you want to start talking to hackers. Maybe Tom can just give us a brief introduction to binary space.
Well, we basically started the binary space hackerspace, mostly because there were a lot of people in the south that had to travel all the way to the north just to get to the Housepack Centurion, which is awesome, by the way. So we decided to start our own little binary space in the Val. Everybody welcome. For more information, go check out the website, binaryspace.co.za. You can join the mailing list. And yeah, come join us, hack, talk, enjoy, have fun. All good. We meet, like Toby said, we meet every Thursday night at 7:30. It can differ a bit between week and week, so just check the mailing list for more information.
Cool. So the mailing list is talking to you, talking about the House for Hack mailing list, right?
No,
or is it a binary space
actually
house?
have their own mailing list.
So go and check out their website, binaryspace.co.za. That's right. House for Hack also have a mailing list, so you can catch up on what we're up to here as well. So go check out the website for that. Also, what we've been doing recently, there's a guy called Peter van der Walt who is from House for Hack Centurion, but he's moving to KZN and to Durban. So he's actually going to be starting a House for Hack in Durban. So we've now got one in Centurion. We've got one in Randburg. And now we'll soon have one in Durban. So you guys out there in KZN, you're more than welcome to jump on the mailing list to find out details of where the venue is going to be. It'll probably be around Riverside or Hillcrest, one of those. So it'll be somewhere there. And Peter, he's quite a busy guy. He's been building 3D printers here. He's got kits that he sells and so on. And he's just started building quadcopters. So here's one of the quadcopters. This is the quadcopter kit that he's currently putting together. So if you guys are interested, you want to build your own, or you want to see how it works and so on, get in touch with Peter van der Walt. He's on the mailing list, or go and check out the one of the House for Hacks. All right.
Yeah, so we'll probably advertise some more details, the costs, when it will happen and so on. But the idea is basically to build a quadcopter looking like that of your own, and take it with you when you go on holidays and wherever you want to take it. So I think that's pretty much enough of the sort of standard stuff. What we want to get into now is the main feature for tonight, which is the USB reverse engineering. And so, Tom?
USB is a way that they try to standardize all peripherals added to a computer. These days, you go far to find something that you can actually attach to your computer without using a USB cable. Everybody knows the USB connectors and such. The whole idea is essentially to just give an overview of how you would go to reverse engineer something. The bigger question is, why would you want to reverse engineer something? A USB device. Well, essentially, let's say you buy a USB device which is totally cool, works perfectly under your Windows, you get Windows drivers with it, but under your Linux operating system, it doesn't work at all because the manufacturer has decided not to release a driver for it. So you can essentially create your own driver if you know how it works. So that would be one of the reasons. The other reason would be to use hardware in a way other than what it was originally intended for. For example, for the gamers out there, you get this game called Skylanders. It's essentially as a portal like this and little gaming characters that you put on it. Depending on which character you put on it, that changes something in the game. So what else could we do with this? Well, one thing that I'm thinking of interested in doing with it is I've got a small kid at home who loves his music, but obviously he's a little bit older than a year, so it's not like I can give him a CD player to change the music and that. So the plan was to essentially, depending on which character he puts on the portal, it will change either the CD track or maybe put on a whole different album on there. It's essentially whatever you want. Or think of your Skype status. If you're online, you put the one character on there. If you're going away, put another character on there. The sky's the limit. So essentially, you're owning the hardware and making with it what you want. So the basic way that the whole USB identifies itself to a computer is by using a VID and a PID. The VID is essentially the vendor ID. For example, Microsoft will have a specific vendor ID, and the PID is the product ID. So for each different product that Microsoft brings out, it will have a different PID, while the VID is the same. let me explain it in terms of the serial port from yesteryear. The serial port of yesteryear, you had one specific port. It was named a specific number, COM1, COM2. The USB, it works a whole lot different. The USB, you can have almost, I won't say unlimited, but you can get quite a few USB ports on them, and including stuff like hubs onto it, then you can expand the USB, which makes it a problem to identify it. So when a USB device gets plugged in, it essentially transmits its VID and its PID to the host computer, and it uses that to determine which driver to use and how to communicate to it. So one of the first pieces of software that I'm going to introduce to you is called USB View. It's a very basic piece of software. It essentially just shows you what USB devices are connected to your screen. Sorry, not to your screen, to your computer.
So it talks to. So you're talking about the different the ways that it communicates.
Exactly. Each USB device sends a configuration to a computer of how you talk to it. USB View is a developer's view into the different aspects or the different configurations for that device, including the VID and the PID. This is a simple utility. You can just Google for it, or alternatively get it from ftdichip.com. Even if you don't understand how to use it right now, it's more of a view program and an actual do anything in a program, but it's got a lot of helpful information with it.
Okay, and it will it runs on Windows and Linux and.
You get a Windows version, and I actually think most Linux distributions already have it included.
Oh, fantastic! So that's good news for Linux guys out there.
Yeah. So to start the whole reverse engineering process, we've got 4 different steps into it. It's basically the same than reverse engineering anything else. You first want to get access to the data, then you want to create an action on the device so that the data would change. And then the third step would be to actually detect that change of data. And if we detect the change of data, then we essentially figure out how it works. So what I'm going to show you is how we capture the data as step 1. There's 2 ways of doing it. We've got a hardware way of doing it. It's essentially using one of these. It's a Beagle USB 12. The nice thing about this is even if you have devices that talk USB with each other, you can put this in between there and still capture the data from that, instead of having a software app running on the computer reading the data from the device.
Yeah, so Tom, I mean, you previously mentioned that they're using these for that Kinect. So initially, the hacking of that Kinect, I'm sure people know about that. That's that 3D camera that comes with the Xbox.
That's correct. What they basically did was they used this to capture a whole lot of data with the Kinect in use, and they stored it on a GitHub. And everybody could basically just pull the logs from there and do their own independent reverse engineering on it, which definitely made sure that it got reverse engineered a lot quicker, and also helped people that would like to participate in the reverse engineering of it but didn't have access to this, because while the hardware solution is very nice, it does get quite expensive.
So can you give us an idea of the price, and where can we find one of these? Because I definitely want one.
You can go to totalphase.com to buy it online. Price-wise, I'm not 100% sure what it is these days, but it is quite pricey for hardware.
Sounds like something we need to make.
Definitely need to make one of these.
There actually have been a few open source designs that started, but somehow it seemed like the guys either lost interest or maybe they ran into a problem somewhere and they never got finished. I think there was even a project on Kickstarter about it, but as far as I know, nothing complete has been made.
Okay.
So obviously, if you can't afford the hardware solution, then we can try the software solution. The software solution mostly that lies on you having software on the PC side that will communicate with the USB, because we're essentially going to sniff out the USB data. We've got 3 different software ones for Windows, we've got 3 different software packages that I have played around a bit with. The first one is Sniff USB. It's an open source app. It hasn't been developed actively lately, but it does still work quite well. You can get all the regular information from there. Plus, it's free, so you can't really complain about that. The only snag that I did see in it, it doesn't like more recent versions of Windows. If you're really serious about reverse engineering a USB device, then rather stick to Windows XP. It'll save you a lot of trouble in the long run. The other two pieces, which are also pieces of software which is quite nice, although commercial, is the first one is USB Trace. It is from sysnucleus.com. It's compared to the hardware, it's a lot cheaper. We're talking about less than $200 for a single user license, which, while it is still a lot of money,
Yes.
it is still a lot cheaper than any hardware solution. So I'm really thinking that the open source, if Housepack wants to make an open source version, it'll definitely help a lot. And then the third one is the USB Laser. This is the one that I've been using the most. It works very well. It's got different class decoders. Class decoders essentially decodes the protocol, and if it sees anything in there that is existing to a protocol, then it will show you specific parts of it already. And the other thing is, if you're only planning to reverse engineer a device for a short term, let's say you've got one specific toy that you want to reverse engineer and you're only going to be working on it for a week or two, both these commercial versions have got a trial available, which is fully, I think, 30 days working. So if you only want to dabble in it a bit and play around with it, then you can definitely download the trial version, and you'll have full functionality to be able to reverse engineer your device. And then lastly, for the Linux users, they've actually, the USB sniffing, so to say, they've got a built-in kernel module called USB Mon, which is also open source, and it's not as easy to use as the hardware, but it is not as easy to use as the hardware, but once you get going with it, you can get all the information. So I definitely, if you're on Linux, give it a go, give it a try, and figure it out.
So have you played with this USB Mon?
I have played with the USB Mon. It can be quite overwhelming in the beginning to get all the data, but nothing that a few grep statements won't filter out. I mean, what I usually do is you capture all the data, tell it, and just grep out according to the VID and the PID, and then you can get the specific data for your device that you're reverse engineering.
Can you tell which direction the data is going?
You can.
Okay.
It will basically, it's in the log, it essentially shows you, okay, it's going that direction or this direction.
Okay.
Another important thing to look at is, unlike serial, which can essentially send anything, the USB messaging sends 4 different types of messages. You get the bulk messages, which is a lot of data, but this is data that is not necessarily supposed to be real time, but it is supposed to be accurate. Then you get the isochronous messages, which is mostly used for webcams. This is data that requires it to be a real-time sending of data, so you want the data as it is being captured, you want it coming in. Thirdly, you get the interrupt data, which is mostly what they used for devices such as mouses, keyboards, etc. And then lastly, we've got the control messages, which is basically used to query a status of something, to set a configuration that's for small, quick data sent and returns. I'm mentioning this because the logging or the capture software that we just mentioned also will show which type of messages you are receiving and what it is sending, which is kind of essential for to re-implement it our own way. And then, that's basically step 1. To capture the data, if you can capture the data, then you can spend time on reverse engineering it. I think capturing is one of the more difficult parts, because you first need to set up your whole process to get the information. But once you have the information, then the only thing holding you back is time to reverse engineer it. So after we get all the data, we will reverse engineer it, essentially.
In a lot of instances, you probably don't even need to reverse engineer because some of the protocols are live, right? So, for example, Skulk and we played recently on using a little AT-Tiny chip to emulate a keyboard or a mouse. And, I mean, that was quite cool because we just download a USB emulation library into the chip, and then we'd plug the chip into a USB port, and then it would pretend to be a mouse and move your mouse cursor around, or pretend to be a keyboard and start typing stuff on your.
That's
and,
correct.
and typically, I think that a whole lot of classes of such devices should already be well known, because they have Linux kernel drivers, usually
Yes.
open source drivers for them, and so on, right?
Yeah.
So an easier way, if you don't want to go the whole reverse engineering, is to maybe take one of these drivers, source code, and then sort of modify it for your needs, right?
Well, yes, but these different drivers, the different classes that identify itself to the computer, like you say, for mouses and keyboards and stuff like that. Basically, to be able to allow the operating system to work with a device without having to install a specific driver. Unfortunately, if, for example, the Skylanders portal, it's very specific only to this game. So while it actually does use a HID class, it doesn't. It still sends data on its own. It uses a specific class to send the data, but it still has its own internal protocol on it. So you get a stream of data. You can read the data, but you still need to be able to figure out what exactly the data mean. You get, for instance, 8 bytes of data, and you've got no idea what the different 8 bytes mean. You know, the first 5 bits could be a color. The next byte could be identification code.
So they've run this device on a standard class and just implemented their own messaging within that class.
Exactly. Right? They use the class for the transfer of the data. So they essentially they can use a driverless class,
yes.
but inside the class they still send the data that they want in their own way. So in some cases it could be as easy as just a basic one of the classes that you can use, and then, like you say, you can use an existing driver and use it for your own stuff. But usually the really fun stuff to reverse engineer is probably not going to work like that. So,
Right.
Do you find that a lot of like devices, proprietary devices, could use like a serial over USB? Because often we work with Bluetooth, for example, and that uses a serial protocol, right? Because it's so easy, you're just transferring data back and forth, and then you can implement whatever protocols you want on both sides. So do you find that like often a lot of these proprietary devices just use one type of class?
well, no, definitely not one type of class, but I have found that the more older models or more older products that you want to reverse engineer uses the USB to serial stuff, and while the more newer ones uses a more proprietary protocol, which makes
maybe just getting back to the reverse engineering. I mean, you've got tools now to capture the data, but in terms of that analysis, any tools there, any software that can help, or is that more sort of left to your skill and so on?
Well, it is partly a skill thing. Although the software that captures the data, some of them do have protocol identifiers in there, and they do show certain stuff. But at the end of the day, it's a matter of observing the data and using logic to figure out what exactly are they doing there. I think it's probably the same. It's an interesting geek puzzle, so to speak.
Okay, well, it sounds like something I would definitely want to get into. I use this language called R a lot. It's all about statistics. Maybe statistical tools can also help a lot in terms of reverse engineering. Hey, Tom?
I think definitely so, and especially in terms of devices that use a type of crypto in the way that they send the data, encrypting the data before sending it. With regards to that, you'll definitely need to use something like that. Okay, well, after we've got our data, we basically need to view the data. Now, the part of our 4-step process is step 1 is capture the data. Step 2 is, while capturing the data, create an action. For example, in the Skylanders, it would be put a character on the portal and remove it. And on your capture stream, something should change because it needs to send that data through to the computer. So the whole idea is to basically create an action, see if something changes, and then see if you can recreate that action. In other words, if you take the character off the portal, then obviously whatever it changed in the original needs to change back. And if you put the character back on the portal, then it would need to, obviously, you need to be able to reproduce it reliably, so to speak. If you can reproduce it reliably, that brings us to our step 4, where you've got the possibility to now implement it in your own software. For instance, with the portal that I want to do, I've written a Python script that reads all the 3 different characters of it and sends through the ID to the it reads it from the device, and depending on the ID of the character on the portal, it will then take an appropriate action with it.
Okay. So in terms of implementing,
For implementing, libUSB is very nice. What they essentially did was they created a USB driver which has a whole lot of configuration options. So what you can do is what you do is basically you set up a VID and a PID to identify the device, and then from there onwards you've got, for all the different types of USB messages, you've got functions to send data and receive data. And the nice thing about libUSB, obviously, that it's open source, and it's got language bindings for a whole lot different languages. So chances are good, what's that language you just mentioned?
R.
The chances are good you're going to have a binding for it to be able to use the libUSB. Obviously, this whole little topic discussion of ours is we've skimmed over a lot. There is a whole lot in regards to USB. There's actually, I think I missed that, there's actually a very good book about it that you want to go check out. It's called USB Complete. It's a developer's guide. You can get an electronic version for the Kindle on Amazon or buy a paperback. It's excellent. It's a very thick book, but it explains everything in very nice detail. So if you're definitely very interested in this, I would recommend get the book. It makes for a good nighttime read.
Okay, well, thanks, Tom. I think that's brilliant. Love to get my hands on some of this. So yesterday we met with Greg, and Greg gave us this modem that uses USB. So maybe this is something we could want to apply to that and see if we can
definitely
get our own drivers for this modem. So brilliant. I think it's pretty much we're sort of out of time for the show. Mixer says yes. One of the regular features we want to add, we can just go through that, is take hack, leave hack. So we've got a box here at Housepack. It's literally a box that people can take, bring some of their interesting toys and leave it there, and maybe take something else to play with. And Toby this week he selected one of these items, and maybe tell us why you thought it was interesting and what can we do with it.
All right, cool. So as Carl said, it's basically anyone can leave something for someone else to use, or you can take something and you're encouraged to leave something back, right? So I rummaged through the boxes, and I must say there's a lot of stuff here. So we'll have lots to talk about in future.
Nice.
I'm going to start with something simple. What this is essentially a motor. It's a servo motor that's encased in a case, and it's got a gearbox in it. Okay. What's really nice about this particular one? First of all, it comes out of a photocopier. Okay, so these things are now being discarded because they come out of old photocopiers. But it's a motor that's driven by 12 to 24 volts. It only takes about 70 milliamps, so it takes very low current, but it provides a lot of torque on this drive shaft here. But what's really cool about this is that it holds its position. Okay, so I can't turn it once it's off. And it doesn't need power to hold that position. So unlike most servo motors where you have to constantly give it power to hold a specific position, here you twist it to whatever position you want with some voltage, and when you remove power, it holds that position. So I can think of a lot of uses for this. There were some projects where we specifically needed this functionality. So I think this is brilliant, and there's quite a few of them in the box. So,
brilliant. So how many roughly was there?
I saw about 4 or 5 of them.
Oh, great.
So there might be more.
I think they'll be grabbed up very quickly, but
cool.
That's great.
So this is there for you guys to use.
Okay. So then I think finally, this is the end of our first show, and we'll probably do a lot more of these. I think it was lots of fun. Thanks again to the mixer, and that's it.
Cool.
Pretty much the end.
Oh,
thanks a lot, guys.
Thank you very much.
Drink the rest of the beer.
Yeah, let's do that. Cheers.
Cheers.